Hello everyone, welcome to this new session. So in the last session we have discussed briefly we have discussed all the concepts of stability analysis using RH criteria, right? So in the upcoming few sessions we are going to solve many problems and very interesting problems. So you will understand it very briefly. So let's get to the first problem now. Okay, that is analyze the stability of the system using RH criteria for having the characteristic equation. They have given it as s to the power 5 plus s to the power 4 plus 2s cube plus 2s square plus 3s plus 5 equal to 0. Okay, so now for this, how many roots of the equation are on the imaginary axis and on the right half of the S plane? Okay, so that directly they have not given to stability. Okay, they have enough after stability analyzing we need to check how many roots of this equation are on the imaginary axis and right half of the S plane. Okay, so if they in the question they have asked that how many roots are in the right half of the S plane, we know that whenever the roots are in the right half of the S plane, the system is unstable in nature, right? So directly if there is no root in the right half of the S plane, we can say that the system is stable. Okay, and also imaginary axis means the system should be marginally stable for that. Okay, so it's not possible in this case since we are not getting any marginal values. So we need to be checking if we are getting any row of zeros in this question. Okay, so in this question, if while we are solving, if we get any row of zeros, then there are chances that the system is marginally stable and the roots might be on the imaginary axis. So that won't be there in this question. So we can directly conclude that there are no roots in the imaginary axis in this question. Okay, so now let's solve this question. So now let's write the route array for this. Okay, start from s to the power 5, s cube, s square. So write it like this. And after that, what to do? First write the coefficient of s to the power 5, that is 1. Then leave one term and write the coefficient of s cube, that is 2. Again leave one term, write the coefficient of s 3, and again leave one term. After that we don't have any terms, so 0. Okay, so here write the coefficient of s to the power 4, this is 1. Okay, leave one term, s square coefficient 2, leave one term, the coefficient of s to the power 0 is 5. Again we have don't have any term, 0. So now in order to find the third row elements, use the previous two rows. So first you 1 into 2 minus again 1 into 2 divided by 1, so that's equal to 2 minus 2 by 1. So 2 minus 2 is 0, so here we are getting 0, right? So see here directly in the while seeing in the, if you observe that in the first column we have got the one element as 0, right? So we need to be using one method, right? That is epsilon method, or replacing s by 1 by z method. So here I'm going to use epsilon method. So before that, let's solve for this element, that is 1 into 3 minus 1 into 5 divided by 1, that is 3 minus 5 by 1, that is equal to minus 2. So right here minus 2, and here we would be getting 0. Here is also again it's 0 only. So now here we got 0, right? So replace 0 by epsilon as I've told you, and again solve using epsilon only. So epsilon into 2, that is 2 epsilon. 1 into minus 2 is minus 2, so we have minus, so this would be plus 2 by epsilon. So here we need to writing 2 epsilon plus 2 by epsilon, right? And here epsilon into 5 minus 0 divided by epsilon, so that is 5 epsilon by epsilon. Epsilon gets cancelled, the remaining value is 5. So here it is again 0. So now these two we need to be multiplying in order to get this element, that is 2 epsilon plus 2 by epsilon into minus 2 divided by 2 epsilon plus 2 by epsilon. So multiply minus 2 this to this term, that is minus 4 epsilon minus 4 divided by epsilon. So here we missed one term, that is minus epsilon into 5, right? 5 epsilon. Okay, minus 5 epsilon divided by 2 epsilon plus 2 by epsilon. So we can cancel this epsilon after taking LCM, that is minus 4 epsilon minus 4 minus 5 epsilon square, right, if we multiply, divided by 2 epsilon plus 2. So okay, this we need to be writing now. So this term, write it here now, that is first write the highest coefficient, minus 5 epsilon square minus 4 epsilon minus 4 divided by 2 epsilon plus 2, and here we will be getting it as 0, and again this term into this term multiply, that is 5 epsilon square minus 4 epsilon minus 4 divided by 2 epsilon plus 2 into 5, and here if you multiply 2 epsilon plus 2 into 0, it is 0 again. So the answer is minus 5 epsilon square minus 4 epsilon minus 4 divided by 2 epsilon plus 2 minus 0, sorry, minus 0. So now I will again summarize what and all I have done. Okay, so here I have taken this term, so applying all the limits one by one, what we will be getting, split this 2 epsilon by epsilon plus 2 by epsilon, cancel epsilon, so you will be remaining only with 2, then apply the limits, that is epsilon tending to 0, so 2 by 0 is infinity, so 2 plus infinity, we know that infinity plus any number is infinity only, so here I have replaced this term by infinity, I have written here plus infinity, and again for this term apply the limits again, so 5 epsilon square minus 4 epsilon minus 4 divided by 2 epsilon plus 2, okay, then apply the limit, so epsilon wherever is there it is 0 0, so all the epsilon terms will be getting cancelled, so the remaining terms are constant terms, minus 4 divided by plus 2, that is minus 2, so now in place of this term I have replaced it by minus 2 and I have rewritten the root array here, okay, and rest all the terms I have written as it is, and also you can see that after rewriting the root array, check the first column, okay, so here the sign changes are, you can see here, so wherever this is 0, right, so we have replaced 0 by epsilon, so in place of 0 we need to be writing epsilon, okay, here plus infinity, after substituting the limits, here we got minus 2 and 5, so you can see that from plus to minus we have one sign change here, and from minus to plus we have one sign change here, so there are two sign changes in this question, okay, so we can say that the system is unstable, so I have written system is unstable, and also since while solving this problem we have not got any row of zeros, right, so here we can say that the system is not marginally stable, therefore no roots are on the imaginary axis, and also they have in the second sub question they have mentioned how many roots are on the right half of the S-plane, okay, so since we got here two sign changes, so we can conclude that two roots, okay, since two sign changes, so two roots, and since the system is unstable, these roots are on the right half of the S-plane, so therefore we can conclude that there are two roots on the right half of S-plane, okay. So this was this problem here, so please refer this problem very carefully, this is a very important problem, that is sketch the root locus of the system whose open loop transfer function is given by k divided by s into s square plus 4s plus 30, okay. So this is the question here, so according to question let's solve it one by one, step by step. Let's solve it step by step, that is step 1 is we need to be calculating number of root loci, right, so the first we need to be knowing how much zeros and poles are there, so in this we don't have any zeros, the number of poles are s into s square plus 4s plus 13, so one pole is at 0 and here is one quadratic equation, so we are having total of 3 poles, okay, so the poles are s is equal to 0, and this equation let's put it in the calculator and find out. The coefficients are 1 4 13, 1 4 13, and the roots are minus 2 plus 3i and minus 2 minus 3i, right, so these are the poles here. So now let's see here we are obtained a complex pole, so that's why again we need to be calculating angle of departure in this case also. So before that, step 2, number of asymptotes is equal to number of poles minus number of zeros, right, so that's equal to 3 minus 0, 3 poles and 0 zeros, so that is 3, so we have 3 lines of asymptotes here, so that's why we are going to get 3 angle of asymptotes, right, that is angle of asymptotes, third step. Asymptotes. So the value of q would be ranging from 0, 1, 2. Since we have 3 lines of asymptotes, so that's why 3 values, that is first value 0, 1, 2. So the angles of asymptotes are theta 1 is equal to first value of q, 2 into 0 plus 1 into 180 degree divided by 3. P minus z is 3, right? So that is 2 into 0 is 0, 0 plus 1 is 1, 180 into 1 is 180 divided by 3. So that is equal to 60 degrees. So this is the first angle. So theta 2 is equal to 2 into the value of q is 1 now, 180 degree divided by 3, and that is 2 into 1 is 2 plus 1 is 3, 180 into 3 is 540 by 3, so that's equal to 180 degree again. So this is the second angle. Theta 3 is equal to 2 into 2 plus 1 now, the value of q is 2, 180 degree divided by 3, so 2 2s are 4, 4 plus 1 is 5, 180 into 5 is 900 degree divided by 3, so 900 by 3 is 300 degree. Okay, so these are the 3 angle of asymptotes we have found now. Okay, so then the next step is calculating centroid. Step 4, centroid, right? Sigma is equal to summation of real part of poles minus summation of real part of zeros divided by p minus z. So sigma is equal to real part of poles, right? Minus 2 and minus 2, so that is minus 4, and since we don't have any 0, so that is 0, divided by p minus z, that is 3, that is minus 4 by 3. Our sigma value we are getting approximately as minus 1.33. okay, so this is the value minus 1.33. so this is the value of sigma. Okay, so now let's calculate the further step, that is breakaway point. So now let's calculate that as well. So this is the formula for calculate breakaway point, that is 1 plus g of s into h of s. They are given it as k divided by s into s square plus 4s plus 13 equal to 0. So 1 plus k divided by s cube plus 4s square plus 13s is equal to 0. So our equation is s cube plus 4s square plus 13s plus k equal to 0. So this is the characteristic equation obtained here, right? So now you need to be computing the value of k separately. So that is k is equal to, if you bring k to one side, so this whole term would be negative, that is minus s cube minus 4s square minus 13s. So now we need to be computing dk by ds equal to 0, right? Differentiation of this term with respect to s, that is minus s cube is minus 3s square minus 4 2s are 8s minus 13 equal to 0. So now for this equation we need to be finding out the roots. Okay, that in the calculator the coefficients are minus 3, minus 8, minus 13, minus 3, minus 8, minus 13. So these are the two roots obtained here, that is minus 1.33 plus 1.59i, and the second root is minus 1.33 minus 1.59i. Okay, since we have obtained in the two of the roots are also complex, so that's why whenever we have a quadratic equation and the roots which we obtained here are both are also complex, so whenever we get both roots are also complex, we can directly write it as no breakaway point exists. Okay, because whenever we get all the roots whenever we get are complex roots, we don't have any real roots along with that, so that's why the no breakaway point would exist in this case, because the roots obtained here are also complex, and after simplifying for breakaway point again we are obtaining complex roots. So whenever we get any complex roots, we can directly write it as the breakaway point would be with respect to would be symmetric to imaginary axis. No, but breakaway point will always be not symmetric to imaginary axis. So that's why whenever we get these kind of problems and we get here as complex, also here also while simplifying we are getting complex, so we can directly write it as there is no breakaway point in this case. Okay, so that's why there is no breakaway point. So now next step, let's first calculate the step number 7, that is point of intersection. After that let's be calculating angle of departure. Okay, so this is step number 7. The characteristic equation is s cube plus 4s square plus 13s plus k equal to 0, right? So now for this we need to be constructing the route array s cube, s square, s power 1, s power 0. Okay, coefficient of s cube is 1, skip one term, coefficient of s is 13, 0, 4, k, 0. So now using these two rows, calculate third row elements. 13 fours are 52, minus 1 into k is k, 52 minus k by 4 and 0, and 52 minus k by 4 into k minus 4 into 0 divided by this term. So numerator denominator side, 52 minus k by 4 would be getting cancelled. We would be remaining only with this term, that is k. Okay, so now k greater than 0, so that's why the above element, that is 52 minus k margin divided by 4 would be equal to 0. If you bring this 4 to and multiply with 0, so that's again equal to 0. 52 minus k margin equal to 0. So therefore our k margin value we are obtaining it as 52. Okay, so this is the marginal value of k. So now we need to be putting that in the auxiliary equation by computing that equal to 0 above the row of zeros, that is 4s square plus k margin equal to 0, 4s square plus 52 equal to 0, 4s square is equal to minus 52, s square is equal to minus 52 by 4, 4 ones are 4 13s are, so s square is equal to minus 13. So s is equal to plus or minus square root of minus 13. So again we have minus term inside the square root, so s is equal to plus or minus j into square root of minus 13 is, square root of 13 is 3.6. okay, yeah, so here we got one imaginary term as the answer for this. So this is these are the 2 point of intersections here, that is plus j 3.6 minus j 3.6. okay, so these 2 points we need to be plotting on the graph. So now we are left with only one step, that is step number 6, right? Angle of departure. Okay, so I'll write the formula and keep, that is theta d is equal to 180 degree minus summation theta p minus summation theta z. Okay, so now let's try to plot the graph for this, and after that we would be calculating the angle of departure also. So let's plot the graph. So this is the rough plot, I've drawn it. So now let's mark the poles and the zeros. So yeah, we don't have any zeros here. So one pole is at origin, one pole is at minus 2 plus 3i, right? So yeah, minus 2 plus 3i, so here is one pole. Okay, similarly we have one more pole, that is minus 2 minus 3i. okay, so after that, after complex pole, we need to join them, right? So join it with respect to origin, right? After that there is one centroid here, right? Because we have calculated asymptotes and angle of asymptotes, right? That centroid is at minus 1.33, so this is minus 1.5, so somewhere here the centroid would be coming sigma. Okay, from this centroid we are going to write the angles of asymptotes, that is 60, 180 degree and 300 degree. Okay, so 60 degree, 180 degree straight like this, and 300 degree means from downward 60 degree. From here this is 60 degree. After that, join those angles of asymptotes. So here one angle and here one angle. Okay, so this is 60, this is 180, and this whole thing is 300 degree. Okay, so these are the three angles. So now we need to be calculating angle of departure, right, for these two poles. So now let's name the poles as pole 1, pole 2 and pole 3. Okay, so now we need to be calculating angle of departure with respect to pole 2. Okay, so theta d with respect to p2. Okay, for that we need to be calculating, since we don't have any zeros, so this is 0, so we need to be calculating only summation theta p. Okay, so for that we need to be calculating theta p1 and theta p3, right? So now theta p1, angle made with respect to pole 2 and origin. That is, we need to be joining these two, right? And this angle we need to be finding in the protractor. Keep the protractor here as center and check for the angle whatever obtained. So it is approximately equal to 124 or 125 if we check it carefully. So it's so we can name it as 123 degree. Okay, so yeah, that's approximately 123. I've not drawn the line correctly, so 123 degree we are obtaining. So that's the first angle, theta p1, and angle made by theta p3, that is pole 3 with respect to pole 2 and origin. We can see that again we have here 90 degree. So that is 90 degree here. Okay, so that's why now we need to sum these two up. That is 123 plus 90. The answer we are getting it as 213 degree. Okay, so that substitute it here, 180 degree minus 213 degree. So theta d with respect to p2 is equal to minus 33 degree. Okay, so this is the angle obtained. So therefore the mirror image theta d with respect to p3 angle is 33 degree. Okay, so these two angles we need to be marking at pole 2 and pole 3 now. That is, one angle is minus 33, right? So from here 33 and from here plus 33. Okay, join them both. This is 33 and here this is 33. Okay, so now also we have the point of intersection, right, which we have got plus or minus j 3.6. Mark that as well. So this is plus 3.6i and here somewhere we are getting minus 3.6i, right? So now we need to be drawing the root locus here. So this is the angle of departure. So the pole from this, so one pole would be moving towards, from this point only it would be moving like this in a straight line, since this whole thing is a part of root locus, because from infinity if you observe we have only one pole, right? Or we can see that we have three poles from infinity if you observe, and those three poles are odd number of poles. So this whole thing is a part of root locus. So that's why, since we have only one single pole and also we have an angle of 180 degree, we can directly say that one branch is moving like this with respect to real axis. It is directly moving towards infinity, and from these two poles, that is one branch would be bending it at an angle of 33 degree and it would be touching, and 33 degree angle of departure and angle of arrival to the point of intersection, it would be bending it to an angle of 60 degree and it would be touching this point of intersection. Okay, same thing here, 33 degree it would be bending first and again it would be moving towards 3.65 minus 3.6i at an angle of 300 degree and it would be touching here like this. Okay, and it would be approaching towards infinity. Okay, so this is the plot for the last problem. Okay, so please note it down, a very important question. Code, that is, we need to analyze the stability of the given system using RS criteria. So this is the same question which you have just solved right now. For that, this is one MATLAB code, simple code here. Okay, which is very important. So here in the first line, write the coefficients of this term here. That is s to the power 5 4 2 sorry 1 1 2 2 3 5. I have written it 1 comma 1 comma 2 comma 2 comma 3 comma 5. Next line is declare n as length of coefficient. Then rout is equal to zeros of n comma ceil of n by 2. This is the opcode for this code. Then rout of 1 comma double quotes is equal to coefficient of 1:2:n. That is where I've told you that we need to be skipping 1 terms. Okay, that is it's given in this way, that is coefficient of 1:2. So 1:2 means skipping one term and going to the second term, that is 1:2:n. So if n is greater than 1, rout of 2 comma 1 is to length of coefficient of 2:2:n equal to coefficient of 2:2:n. Okay, if whenever the n is greater than 1. Okay, that is length whenever it is greater than 1. So here in this case it is greater than 1, since we have a length of coefficient as 6 here, so this condition applies. And the code then for I equal to 4:n and for j equal to 1:CL of n by 2 minus 1. So this is the declaration, that is rout of I comma j, it is minus determinant of that only, that cross multiplication is there, right? That only we are doing here. So this code is for that cross multiplication only. Then end the code. Then if rout of I comma 1 equal to 0, rout of I comma 1 equal to epsilon. So whenever in the first column we are getting any term as 0, it is replaced by epsilon, right? So this is the opcode for that. EPS, you need to be writing EPS. Then after that end, then stable. So whenever the system is stable, all rout of colon comma 1 is greater than 0. I've told you, right, whenever the system is stable, we need to be getting all the first column rows as positive. Okay, positive indicates that all the numbers are greater than 0, so therefore they are written it as greater than 0. Then display rout array, then display rout, then if stable. So if stable, we need to display that the system is stable and all elements of the first column are positive. Else display that system is unstable, there are non-positive elements in the first column. Non-positive means there are some negative elements. Okay, so this is one simple code. So according to this code, we have got an answer here, that is the same answer here. So here this answer is not matching, for this is for different code, but the output for this code is, I'll write it here, that is 1 2 3 1 2 5 EPS minus 2 infinity 5 minus 2 5. Okay, so this is the output which we are going to get if we run this program. Okay, then here we can say that the system is unstable, since there is a sign change here, right? So therefore system is unstable, there are non-positive elements in the first column. See, the non-positive element is minus 2. Okay, so this was one simple MATLAB code here. So this is also very important, so please note this code down, and output which we are generating also note that down.